We're going to look at evaluating logarithms. So this is actually exponential at the moment, okay? And we're going to look at solving for the value of t in this question. And we'll do it 2 or 3 different ways. Just keep in mind, and this is probably the second way we'll solve the question, that if we have an exponential function like this, it can be rewritten as a log in this form, where our a value becomes the subscript of the log, the x is what the log is to, and it is equal to y, which would be our exponent in our exponential function. Okay, so maybe always keep this on the side of the piece of paper so you guys can refer back to it. Okay, so one of the methods we can use for this, technically without using logs, is we can try to turn this number on the left side of the equation into a base 3. And that method, using that method, we might have to do a bit of trial and error. So we can take out a calculator here, and I know 3 to the base 4 is 81 already, so I'm going to try 3 to the, and I don't have to write that, that's only on a computer I have to write that, sorry. I'll write 3 to the power of 5, and we'll go through and see until we can get, or a value that's hopefully equal to that. So our 3 to the power of 5, there it is. Well, that's, sorry. 3 to the power of 5. 243. I'll keep it just in case it's handy information later. 3 to the power of 6. 729. 3 to the power of 7. Should we put money on it's going to be this one? Yeah, 3, 7. Woo! Okay, so we got it. 2187. And what that means is we can now replace our 2,187 with base 3 to the power of 7. So let's rewrite this equation now. We have 3 to the power of 7 is equal to 3 to the power of t plus 1. Okay? So because our bases are the same, what we can do is now work this question as just exponents. And there's technically a rule in terms of how to get rid of the base, and it's a log law. But that's probably your next lesson, so we'll just focus on this way here. You guys may have seen this in another class, where now we can just take the number 7 and set it equal to our t plus 1. Sorry, I changed colors there. And what's t going to end up equaling in this question? 6. Very good. Excellent. Okay. Let's use this method now. So let's take our exponential function. So I'll rewrite it again. 2,187 is equal to 3 to the power of t plus 1. Okay, and we'll kind of try to relate them to exponents here. So this 2,187 would be our x value. The a value would be our base 3. And the y value would be the t plus 1. So if I was to rewrite it this way, okay, that y value then becomes what this equation is equal to. So I'm going to take the t plus 1. T plus 1 is equal to, we write it as a log. The subscript of the log is the a value, so log 3. And what the exponent was equal to, which was our 2,187, that now becomes our value in the log, so 2,187. So one way you can do this is now essentially type this into a calculator, but not all of our calculators have this. In fact, the one I have does not do anything but log base 2 and 10, I believe. So you can take a look there. I only have base 2 and 10. So what we can do if we have a calculator that doesn't do this, and again, you'll learn another method with the laws and a way to solve this. What we can do is something very similar to the other page. I can turn this into a base 3. I'm going to talk about why. We already know that 2,187 is 3 to the power of 7. If you hadn't known that, you would have kind of had to go through this process again. Okay. So what I'll do is now replace that 2,187 with log 3, and then it will now become 3 to the power of 7. Now I mentioned this maybe 2 days ago. When you have this relationship where your subscript is the same as if you have an exponent in your log, the base of the exponent, when those two are equal, okay, this can all be simplified by just writing the exponent 7. Okay, so log subscript 3 to the 3 to the power 7, if you had a calculator that does this, is actually just equal to the number 7. Okay, and this is actually a method that's used to simplify logs quite often. If you can get the subscript and the base to be the same, it's whatever the exponent is of the base, that's what it is equal to. Okay, so we get our number 7 now is equal to t plus 1, which means t is equal to 6. We figured it out twice. And then finally, remember that program I talked to you guys about yesterday? We have the option, you can use a graphing calculator. It's one of the things they say to use in the book. So if you have a graphing calculator, I put my function in. Now on a graphing calculator, I can't call my exponent t because the way it graphs is going to be using just x and y, right? So I'm going to change the value of t to the variable x, okay, and I'm going to set it equal to y. Your graphing calculator might be able to graph with an actual value in there. Mine wasn't. So I wrote it as a function of x, or I can also write it as f at x, right? So I wrote it as a function of x. And then to figure it out, I just wanted to find out where it would intersect a line where the y value would be 2,187. So that's very high up in our y values. So I'll scroll out. You would probably have to just change your scale if you guys had one. And lo and behold, okay, at 6 is where this would intersect at 2,187. So 3 different times we've come out with the answer 6. I think we got it. Pretty bright. You guys are so smart. Go through one more method that's technically algebraic. Okay? So we'll rewrite our question again. 2,187 is equal to, oh, I already forgot what it was. What is it? Okay, 3 to the power of t plus 1. Okay, so one of the ways we can do this is we can find the log subscript or base 10 of both sides. Okay, so I'm going to find the log, and you don't have to write the subscript 10, but on your calculator, that's what would be there. So we'll find the log base 10 of 2,187 is equal to the log of 3 to the power of t plus 1. And the reason we do this is whenever you get this, whenever you get a log of some exponent, you can simplify the way this is written by taking the exponent, bringing it down in front, and multiplying it by the value. Okay, so I'll write that as our next step here. We're allowed to take this, bring it down, and use it as almost like a coefficient of the number. So again, we would have log, I won't write the 10 in this time, base 10. And here we'll have our t plus 1 times log base 10, 3. Okay? Now that we have that, this is essentially multiplication between these two values. Okay? And we want to get our t by itself whenever we're trying to isolate a variable. So in order to move log 3 to the other side, what does it need to do? You need to divide both sides by log base 10 of 3, log base 10 of 3. On this side, it creates a 1, okay, or cancels out, whatever they want to call it. We'll have t plus 1 on this side, and here you can actually use base 10 in most of your calculators. So what we'll use is we have log base 10 of 2,187 divided by log base 10 of the number 3. And lo and behold, we get the number 7 again, which is again what we'd found the other 3 times. But this is an actual hard fast rule we can use where we don't have to use any trial and error. And then here again, t will equal the value of 6. This is called the power rule of logs.